Okay, I'm very pleased to have Dr. Gary McGraw join me today to talk about software security. Gary is the Chief Technology Officer at Cigital Incorporated, which is a software security consulting firm that provides services to some of the world's best-known companies. And Gary is a highly regarded expert in the field of software security, having written or co-written 6 best-selling books and more than 100 peer-reviewed scientific articles on the topic. He also hosts a regular podcast called The Silver Bullet and writes a monthly opinion article that has found its home in many publishing houses over the years, but is currently at Search Security. Gary is also on the advisory boards of many companies and universities, and in fact, he serves on the advisory board of the Maryland Cybersecurity Center, which is a nexus of cybersecurity research and education here at the University of Maryland. Well, Gary, welcome. It's really great to have you here.
Thanks.
So can you tell us about how you got involved in computer security, maybe a bit about your background?
I got started in computer security in a funny way. You know, really my BA from University of Virginia is in philosophy. So I was a philosophy major in college. But I've been coding since I was 16 years old. I had an Apple II Plus in 1981 and tried to figure out how to make that work and computerize my high school and so on. And then I went to do philosophy, but I got into philosophy of mind, and I read Doug Hofstadter's book, Go to Lesher Bach, which had a big impact on me. In fact, I went to get my PhD with Doug later. And I started thinking about computers and minds and brains and the relationship between these things. So I went to get a PhD in cognitive science and computer science, which I did at Indiana University. While I was there, of course, Indiana is a great place for programming languages, and just like you, I'm a huge programming languages aficionado. I guess that's because Dan Friedman was there, and Dan's so dang good at lambda calculus and scheme. So I'm actually a scheme weenie as well. And so I started thinking about those things, and then I went to do a startup at a company called Reliable Software Technologies. There were 6 people there at the time, and they'd just gotten a big DARPA grant to work on taking some software safety technology and applying it to computer security. And I got involved in that project, and it made me start thinking about computer security for the first time. Now, this was really 1995. And at the same time, Java came out. And of course, Java was a language, and there were people talking about Java is secure, blah, blah, blah. So my understanding of languages and this new field of computer security and all that stuff all came together, and we started breaking Java. I wrote that book, Java Security, with Ed Felton back in 1996. And then I guess after Java Security came out, started thinking, why is it that these amazing people, like Guy Steele, who's really one of the best languages people we've ever produced on the planet, or Bill Joy, who wrote Berkeley Unix all by himself, basically, screw these things up when it comes to security. And if you were somebody who was trying to build a system like that, like Java, where would you go to learn how to do this stuff right? And there really were 0 books on software security at the time. So I wrote Building Secure Software with John Viega in 2001, 13 years ago, believe it or not. And that's really where it all came from. That's how I got dragged kicking and screaming into computer security, and how I've come to be a software security guy.
Actually, I was looking at your book recently, your 2001 book, and I'm amazed at how well it is aged. That maybe this is a sad state of affairs, but many of the things that you guys write about are still important issues that people need to worry about today.
Yeah, even though that book, Building Secure Software, is 13 years old, we really wrote it as a philosophical treatise. So it had a lot to do with what the problem was, ways to approach the problem, what we should do about it. There was even a chapter on early approaches to static analysis, you may recall. So everything in that book still applies, but I do believe we've made a great deal of progress in the field of software security, some of which has been written down. In particular, we understand what kinds of activities belong in software development life cycles today, and we're beginning to understand how to scale those sorts of activities to armies of developers, 15, 30,000 people at a time.
So speaking of building secure software, As you've already hinted at, you're a passionate advocate for building security in, as you like to say.
Yep.
Can you say more about why that's so important and maybe why it's so neglected?
Yeah, I think that the beginnings of computer security had a lot of focus on protecting the stuff from the bad guys by putting a thing. You know, it was a kind of a network operations approach to computer security. And the big insight was, well, you know, you're protecting broken stuff from the bad people by putting a thing, which we call a firewall to this day. Why is this stuff broken? And you know, people were all like, "Oh, wow, that's a good question." And then the obvious next question is, what do we do to make stuff less broken? So it's a paradigm that sort of came second in computer security, and as a result, you still see network security accounting for about 90% of computer security spend out there. You know, it's about a $30 to $40 billion industry. But software security is growing at twice the rate and is now probably a $2 to $4 billion industry itself. And it's taking over, you know, so it used to be we were nothing if you looked at the two hands of computer security, and now we're at least the pinky finger. So that's good, and growing fast.
It seems like one of the things that I suppose is at least part of the reason for why software security is neglected is that it's hard to build software that's secure. That if you can ignore the software and just stick a box on your network, even if that doesn't work, we'd like to pretend that it works, and so that's what people do. Can you say a little bit about maybe why building security software is so hard?
Yeah, I mean, the big issue is one of who's doing it. So the traditional computer security people in an organization are network security operations people, system administrators, and so on. So these people that have been tasked with defending networks are not really software people. And they install applications, and they like to call this field application security because they're trying to figure out what's wrong with these applications that ruin all their perfect network stuff. But the people who need to practice software security are developers and architects and system designers and really the business people who make these systems up from scratch. So we have a new audience of people to address. And those people are very much willing to learn about software security, but it's pretty new to them. You know, we've been doing it for a decade or more, but there are lots and lots of developers out there, probably 8 million. I think we've touched about 250,000 of them so far, so we're 1/29th of the way there.
So speaking of people being unaware of computer security, I'm thinking about computer security courses, courses that teach material like this course teaches, but probably they focus a lot on the hacks, like buffer overflows, SQL injection, cross-site scripting.
Yeah.
Maybe they teach about access control and crypto, and these topics touch on building secure software, right? We avoid buffer overflows, use crypto when you're on an unsecured network, and so on. So they illustrate weaknesses and present some mechanisms, but maybe they're missing important topics. What do you think that these courses need to be teaching so that developers are aware of what's going on?
I think it's great that these courses are touching on security at all. And in fact, I think the key is to teach some of the stuff that you mentioned during normal development courses. Like if you're learning to program in C, you should be taught, by the way, watch out for buffer overflows, just because it's C. So there doesn't have to be a special set of courses, although that's great too. But we need to integrate software security throughout the entire curriculum. I think that's very, very important. I think the hardest thing that we don't know how to teach yet today that we're still working on is design. But we don't know how to teach software architects. Like, where do software architects come from? The answer is, it takes an army of a lot of experience, and one day, 15 years later, you turn around and you go, oh, wow, there's a bunch of people asking me what to do all the time. Let me put down this keyboard and pick up this whiteboard marker. And, you know, you sort of never code again, and you became an architect. But architects have as much to do with software security as coders. So this notion of writing secure code is very, very important, and it's not to be ignored, but it really addresses about half of the problem. The other half of the problem has to do with design. And so when we focus on both secure design and security engineering from a design perspective, and secure coding and security engineering from a coding perspective, we'll have a much more robust approach to the problem.
Okay, so let's maybe talk a little more about the software development lifecycle. So the traditional lifecycle has requirements engineering, what does the software need to do, design, as you mentioned, how do we organize the software so that it does what we want, then implementation, how do we actually implement it, and then finally testing or assurance, how do we know that it actually does what we think it's supposed to do.
Yep.
And of course these activities are often iterated throughout the development process and then even after deployment. So what I'm wondering is, well, where does security fit in terms of this traditional life cycle that people might know about but haven't been thinking about security at least as yet?
And you know, maybe not ironically, I'm going to give you the same answer as I gave you with the curriculum. Everywhere! So my approach to software security and the SDLC, or SDLCs with an S, as the case may be, is to think about software artifacts that get produced no matter what your SDLC is. So you may be doing Agile, or you may be doing CMM level 57, or you may be doing Scrum, or who knows, or just an iterated waterfall or a spiral model. It doesn't really matter. You do create these artifacts, and you should consider these artifacts from a security perspective. So if you're thinking about requirements or user stories in the Agile case, you need to think about abuse cases and anti-requirements. If you're thinking about design and architecture, you need to think about threat modeling and architectural risk analysis. If you're thinking about implementation, you need to think about choosing the language is really a key decision. So which language should you use, and then how do you look for and eradicate bugs using technologies like static analysis? When it comes to testing, and I'm talking about testing before you've released, so you need to think about security test cases and test cases that are based on those abuse cases from earlier in the life cycle, and intentionally pushing the limits of edge cases and corner cases so that you're not just doing functional testing. You, of course, need to do normal functional security testing on the security features, because there is such a thing as security features. But remember, we're not just interested in features here, we're interested in that property called security. And those features can help us get to that property, but they're not the be-all, end-all by themselves. A really easy way to think about this is security is not cryptography.
Right.
Then moving on in the life cycle, when you finally release, you do need to do some penetration testing. It's always a smart thing to do, but hopefully if you spent time earlier in the life cycle eradicating security defects, you're not going to find much when it comes to penetration testing. Unfortunately today, a lot of firms that are just starting out in software security begin with penetration testing, which finds all sorts of problems. Now, the good news is it disavows them of the belief that their software is perfect, but the bad news is it's very expensive to fix problems that you find after a software project has been shipped, right? And so even with live update and all that stuff, it's still penetrate and patch is a very silly way to approach things economically. So all of those activities are what I call the software security touch points, and that in fact is what my book Software Security, which was published in 2006, is about. And that book remains utterly relevant today because there are whole industries that are just beginning to take on software security. We've made a lot of progress in financial services. We've made a fair amount of progress in independent software vendors, but we've got medical device manufacturers, we've got retail and hospitality, we've got gaming, we've got all sorts of, retail, well I said retail, all sorts of disciplines that are just beginning to take a look at software security and figure out what they should do. So the good news is we know what you should do. The bad news is you need to start doing it.
So you, I'm going to talk about or ask you about the building security and maturity model, which talks about how companies are starting to adopt these practices, and that's something that you developed. So we'll spend a few questions on that. Before I get to it, I'm thinking that one thing that might get in the way of people wanting to implement security practices in their development life cycle is the perception that it's just really hard.
Right.
That figuring out how to change everything that they do to sprinkle security in, and what does security mean, and how does an architect think the right way, and so on, is just very difficult. Is there a way that we can get those traditional security people, or we can create a new kind of security person who can help developers and architects and so on within an organization move toward better practices?
Yeah, that's a really tough question. I think the answer is you do have to have people whose job is to focus on that and who really are developers. They're not working with developers, they are developers. And they're not just working with architects, they are architects. And so the real answer is to pervade this approach to software security to all software people. But that's going to take a while to sink in. It's kind of like pouring water. It has to get to the roots, and it's happening, but it's not happening super quickly. In the meantime, there are a lot of people who are helping large development groups. Some consultancies like Cigital, we have 350 people now, and we're growing really fast. Some tools companies like Coverity, you talked to Andy last week, or Fortify, or the IBM AppScan people, and there are others that produce tools that can be used by developers, and just in general an understanding of computer security and its importance. The good news is that I think even people on the street know about computer security now. And I got to tell you, when I started doing this in 1995, they didn't. I mean, there was sort of a hacker thing, but it was way over there. And now everybody's like, whoa, computer security, and they always know what that is. You don't have to start by explaining what that is. That's good. Now we have to say, well, the real way to approach this problem is not to sprinkle magic crypto fairy dust or put a firewall or get off the net or, all of these silly approaches. The real answer is build stuff to be secure. Now, is that difficult? Yeah. But is it hard to build a quality car versus a crappy car? Yeah. You remember when American cars were crappy? You were probably a kid when American cars were crappy, and some of the people listening to this weren't even born yet. But American cars used to be crappy. First they were the best in the world, then they were crappy. And everybody said, why are our cars so crappy? Gosh, it's so hard to build a good car. How are we going to do that right? And it's the very same issue. Quality and reliability and safety and security are all these emergent properties that we want out of our systems, and we do have to do some hard work to get those properties.
So let's talk about some of the hard work that companies are doing that you've managed to uncover in the building security and maturity model. So could you tell us about that model and maybe a little bit about its history?
Yeah, we call it the BSIM for short, and you can download the whole thing and check out everything that we've written down at the website bsimm.com or bsim.com. Everything's released under the Creative Commons, so it's totally free, and it makes a really good teaching tool for advanced students, for example. What we did was we went out and we gathered data from in the beginning, 9 firms who were practicing large-scale software security and had software security initiatives. To give you one common example that most people have heard about, Microsoft has what they call their Trustworthy Computing Initiative, and they've developed what they call the SDL out of that. They are one of the 9 firms that we studied when we gathered data to build the BSIM model. The idea was, let's go out and find out what firms are really doing, not theory, not what they're gonna do, but what they're actually doing today, and let's write all those activities down and describe them. And so we started with 9 firms. Now we have, I think it's 83 firms. The last published model has 67 firms in it. BSIM 5 we released last October. We're probably going to release BSIM 6 sometime in the spring of 2015. I'm shooting for 100 firms, which is very, ambitious, but I think we can get there. And the notion is to have this model be based on describing the world as it is out there in software security initiatives. These are 83 real software security initiatives at every single major international bank on earth, almost all of the ISVs. And it's a way of describing what they do and then measuring that. And you can actually compare belly buttons. You can say, gosh, everybody else in the world seems to think this particular activity is important, but we're not doing that. Why do they think that? Is that good for us? So it's not really a prescriptive model. It doesn't say, you should do this. What it says is, everybody else is doing these things. Maybe it's a good idea for you to think about those. So, just to cycle back around, once you have a measurement tool, you can begin to much more strategically approach your software security initiative, and you can begin to tell, whether you're world class or whether you're in the middle of the bell curve or whether you're way behind. And it's easy to tell with the BSIM, so it's a very powerful tool, both for strategically planning and implementing a software security initiative, but also getting budget from the board and showing that you're making real improvement. One of the challenges in security, I got to say this, is from a business perspective, if your job is to make good security stuff, then guess what the best result is? Nothing happens. And in business, you're like, wait a minute, let me get this straight. You spent $5 million and nothing happened, and next year you want to spend $6 million, but nothing happened, and you have to say, yeah, the reason that nothing happened. So it gets a little bit challenging, when it comes to security, but that's the way things go.
So can you describe maybe some of the elements of the BSIM and perhaps relate it to some of the things that we've discussed so far, just to give people a flavor of how it looks?
Yeah, there are 12 practices in the BSIM, and the practices each have individual activities. So an example of a practice that's easy to understand under the governance heading would be training. How do you train all your developers? How do you train your product managers? How do you train your executives to understand what's going on with software security and to get engaged in the initiative? So there are, like 12 or so activities under training. I don't remember the exact number. Another practice is architecture analysis. Another practice is source code analysis. And another code review. And another practice is security testing. And so you can look at standard touch points as a practice area, and they all have particular activities inside of them. The activities themselves inside of the practices are divided into 3 levels. Really easy stuff is level 1, and lots of firms do the really easy stuff. Slightly harder stuff is level 2, often requires level 1 stuff to be done first, and then you can move on to level 2. And then level 3 is rocket science. And there are some firms that are doing rocket science stuff, but everybody doesn't have to do that. It's just good to know what everybody does. So you can think of the BSIM model as a Venn diagram of overlapping software security initiative shapes from different firms and the popularity of various activities, which really has been driven by the market and driven by these firms that really want to get this stuff done. Just to give you some sense of scale, in those 67 firms in BSIM 5, we actually are controlling or helping to impact the work of 267,000 developers. So that's a lot of developers, almost just more than 250,000 developers. It's not enough, but it's real. This is not, some little tiny science project or some theory. This is, really very impactful in the real world.
Actually, that makes me wonder, since you've been working on BSIM for quite a while, this is the fifth iteration, and
Hmm.
you're up to, well, I guess you're in your sixth iteration, but you had those 9 companies at the start and then 67 in the most recent. Have
Yeah.
you been able to chronicle the evolution of practice of those companies and maybe even attribute some of that to those companies having been in BSIM?
Yeah, actually we have. And since the BSIM is a data-driven model entirely, we're very much concerned with making sure that the model describes the data and not the other way around. So remember, it was data first, model second. And that's always driven us. So whenever we take a new population of companies and add it to the data set, we revisit the model and make sure that it actually describes the data. Um, yeah, I guess the biggest thing that's caused companies to move in terms of BSIM work is we asked the firms when we reached 30 in statistical significance, what do you guys want out of this project besides knowing how tall you are and how you compare with all your peers? And they said, ooh, we have peers. We want to meet those people. Can you, like, introduce us to those guys? And so we set up a conference, and we're getting ready to have our 5th conference in November of 2014. It's going to be in Monterey, California this time. And we're going to get together all of the member BSIM firms who can make it. And the conference is incredible. They give presentations. It's presentations from the firms themselves about what works and what doesn't work in terms of real activities, real tools, real scalability, what the problems are, how you get budget for this stuff, how you measure it, what you do when you have a crisis, and introducing these people together and helping to stimulate that conversation and keep it aimed in the right direction has been an incredibly powerful experience, and something that when we were building the BSIM as a scientist who was driven by data, I didn't even have that in mind. But because of that, there's lots of sharing and there's a real community that's developed around the BSIM.
Is there any chance that some of those experiences, some of the data that these companies have gathered, could feed back into creating some evaluation? So, for example, you mentioned there are these 3 categories of recommendations: the easy stuff and the rocket science.
Yeah.
You could also imagine, these are both easy and highly effective
Yep.
as compared to some of these others, which would be great to have evidence, say, from these companies to make that assessment.
You're right. And actually, this notion of effectiveness is much trickier than you would think, because there are very few externalities, to put it in economic terms, that you can measure that allow you to determine security effectiveness. Right? You can always do a test of a particular project and look for vulnerabilities, but that's just a point. That's a data point. And when there's an event, that means there was a problem in that application or that software, but the real question is, what about the problems that got found earlier in the software lifecycle? Now, the real tricky bit is that all these companies, a lot of them actually know that, but they don't want to share those data. Microsoft does not want to tell you how many security bugs they find themselves and fix. They're just not interested in underscoring that their developers still need help writing perfect code. I mean, nobody wants to say that, and you can't blame any individual company for that approach. So the data do, in fact, exist, but nobody's sharing those data. Every time we've tried to approach the problem of efficiency and effectiveness, we've come up with stuff that's just not powerful enough to hold scientific water, in our view. So in some sense, if you think about this from a pedagogical perspective and you think about this from a science perspective, we've had to retreat from a first-order measurement to a second-order measurement about process and about activities, and sort of work under the hypothesis that those activities jointly give you better security. But there's no direct measurement of security, so that's what we have to do. We're stuck with that. It's sort of a bummer for me. I'm a code guy. I always used to argue with the process guys. I had so many arguments with the guys at the SEI before. Like Watts Humphrey and I had some colossal arguments back in the day. And I find myself, I guess, when I get older in my mid-40s, building a process model that scares the bejesus out of me. But I think that ultimately that's the way you have to approach this problem, because we have no great way of measuring software or software security other than the BSIM.
I think that from my own perspective, one thing that's nice about BSIM is that because you're making a good model abstracts what many things are doing and pulls out what the most important elements are. And it's hard work making a nice descriptive model that doesn't leave out important bits.
Mm-hmm.
Once you've done that and you've done it and it really represents what lots of companies do, then other people can start to study those practices. So maybe the companies are not going to give you the data, but those people can look at their BSIM model and then can look at how many security incidents they have, or use other studies. For example, within the companies could do them themselves, or academics could come in, and then they can start asking. You've created a way to frame the question so that that future research can happen.
I think that's right, and I think that there are companies that are doing those exercises already. I mean, everybody who has an existing software security initiative that's working well wants to make it more efficient and more effective. And so there are sort of lots of natural experiments going on among the top 20 BSIM firms just addressing that issue. And in fact, I get them to talk about them at the BSIM conference. So we are making some progress. But yeah, that's a real challenge. I mean, there's this issue too, Michael, and you guys in academia can help with this. So there are some vendors who are pretending that you can take a piece of code and stick it into the magic box, whoop, and the magic box will turn green if everything's all right, or go if there's a security problem. Well, either those people are really bad computer scientists, right, or they're charlatans, and neither answer is good. So either they're hucksters lying to us, or they don't know a damn thing about computer security. And so an understanding of theory, of what the halting problem is, of what levels algorithms take to do certain analyses, all of these things have to ground the field of software security. And if we let it just lift off like a sort of an ethereal balloon and become filled with baloney, then it's not going to be a very useful field. So it's important for us, when we're talking to students, to go, look, there is no magic box. Everybody wants a magic box. But we can't even build that from a theoretical perspective. So let's stop trying to pretend we can build a magic box or sell magic boxes. Let's get down to the hard work of actually building code that doesn't suck. And that's what we're doing with the BSIM.
Fantastic. Let's see. So I guess to some sort of wrapping up questions. So one is, as you said at the beginning, I think we have made a lot of progress in making things more secure. I wonder if you have thoughts about things that are most important to do next. Maybe I can answer my own question with the answer you just gave, which is there is no magic bullet. But maybe there are things that, for example, the BSIM has revealed that are particularly underappreciated,
right,
or are suggestive of something that's really a breakthrough on the horizon. Is there anything like that that comes to mind?
The hardest problem that all of us have recognized who practice software security is one that I've already alluded to, and that is the problem of security architecture and security design. There's an overfocus in the field on what I like to call implementation bugs, as opposed to design flaws, which have a superclass called defect. And if you want to address all of software security, you have to address all defects, not just half of them. So some focus on design flaws and how to avoid design flaws is what we need. Now, we put together a workshop, we being the IEEE Computer Society, put together a workshop in April for something that we call the Center for Secure Design. And that involved 13 representatives from 10 different organizations and companies who came together to think about, gosh, if we had to build a list of the top 10 design flaws in software, what would that be? And believe it or not, nobody's ever written down the top 10 design flaws. I mean, there are top 10 lists of bugs all over the place. There's a OWASP one, and a SANS one, and Joe's one, and Bill's one. And, everybody talks about buggity, 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 bug. But no one's ever talked about flaws. So the price of admission at this workshop, which was the foundational workshop for the Center for Secure Design, was you must bring a bag of flaws, and it has to be real, and you have to dump it out on the table, and then we're all going to talk about real flaws and real systems. So we had representatives from Google, from Twitter, from HP, from EMC, from RSA, from Harvard, from University of Washington, from George Washington University, National Science Foundation, DARPA, Cigital, all putting these things together. And we created a report that we're going to release in, I guess it's 26 days, 20 days, 18 days, on the 26th of August in San Francisco when we launch the Center for Secure Design. So I think that if we really rally behind that sort of work, we can begin to better understand how do we do threat modeling effectively, how do we do architecture analysis effectively, and most importantly, how do we scale that to the enterprise level? Because we can always have a few Superman-esque people that are running around doing design analysis, and it just doesn't scale, and we have a really big problem to attack. So the real issue is, how can academia get involved there? And frankly, I think academia has a hard time understanding how to teach software architecture in the first place. And so I think some pedagogical breakthroughs are required in order to address this design and architecture issue. And if you think about how architects of buildings get created out in the world and certified, maybe some analog makes sense. I'm not really sure, but it would be great to have you guys in academia working on that problem. So I think that over the next 10 years, we're going to shift from what I call the age of bugs, which is what we're in now, to the age of flaws. And so we've got our work cut out for us. There's plenty to do. By the way, anybody who's listening to this class, if you want to make sure that you have a job, pick software security as your field. You'll be paid. You'll be overpaid for your whole career.
Silver lining.
Yeah.
So, in my final question. So, putting security aside for the moment, I understand that you're a musician and you play in a band in your spare time, however much spare time you might manage to get.
I don't watch TV, so.
So what do you play? What instrument do you play? What kind of music do you play?
I play the violin, and I've played since I was 3 years old. I was a Suzuki method violinist when I was a kid. Played in Carnegie Hall twice, when I was 10 and when I was 16, and played with a bunch of symphonies. Then in college, I started learning to improvise and doing improvisational stuff. And then after grad school, I started writing music with friends. I have two bands. One is called The Bitter Liberals, and we're actually releasing our second CD on Saturday in Berryville. Come on down, Michael. We need an audience. It's all original music that's kind of Americana. It goes across a lot of different genres. But it's all music that we wrote ourselves and we recorded at a professional studio. And so we're going to release that. If you are interested in the music, you can go to thebitterliberals.com, and it's all there. The music's actually up now for free. The other band is called Where's Aubrey. Where's Aubrey is a collaboration with another college friend of mine who lives in New Hampshire. And he and I have been writing for years, and whenever we play a concert, we'll always take the money and give it all to charity. So we play big concerts, and then we'll give a couple $1,000 to a charity of choice. Because we all have real jobs. But music is an important part of my life, and I think that, you can see the background here. You can hear the stuff that I work on every day is technical. But having a well-rounded life also means, putting yourself in a comfortable place where you can get lots of work done, and having some art in your life as well. And so I think all those things add up to what is a good, high-quality, well-rounded life, and I would encourage everybody who's deep geek to get some art in your life as well.
Yeah, I mean, it didn't occur to me until after I became a computer scientist, but I like to play music too, and I realized that what we do, what we've been talking about, like secure design, writing code, these are creative activities. You are making something. You are thinking about how to make it and make it well, and it's tickling your creativity in ways aside from writing code will only make you a better coder. And I suspect good coders can be really amazing musicians, maybe much different musicians than if they weren't coders.
I think that's right. You know, when I went to grad school, I went to study with Doug Hofstadter, who wrote that amazing book, Gödel, Escher, Bach, which everybody should read if you haven't read it. And it's about the intersection of high-end computer science theory, hardcore math, and Gödel's incompleteness theorem, art and self-reference in Escher, and music and self-reference in Bach, and what it means to be a conscious entity. So even the most tricky problems in philosophy and in what it means to be a human involve computation in really important ways.
All right. Well, Gary, I want to thank you profusely for taking the time. I've been really enjoyed chatting with you, and thanks for sharing your wisdom with our viewers.
It's my pleasure, Michael. Thanks.
All right.